Okay, today we're going to be talking about advanced conditions in JavaScript. So when we do advanced conditions, there's two ways to do that. One is through logical operators. That's how we'll start the presentation today. Logical operators help us create compound condition. They produce a Boolean value of true or false. One of the keys that we have to remember is that when we're writing compound conditions and using logical operators, both sides of the logical operator have to have a complete relational condition. So writing something like this, num equals 1 or 2, is not valid. This is a complete relation. It evaluates a true or false. This is not a complete relation, so the statement is invalid. Something like this has to be written as num equals 1 or num equals 2. And then the last part is there's three relational operators we'll be talking about. Double ampersands is and, both parts must be true. Double lines is or. Those lines, by the way, are found above your enter key on your keyboard using shift. That means or, at least one part must be true. And then the exclamation point means not. It changes the Boolean value to the opposite. So let's take a closer look here at and. Let's assume that today is a sunny Monday, regardless of the weather or the day. We'll pretend that it is a sunny Monday. Take a second and determine if you think these statements are true or false. Today is Monday and the sun is shining. Today is Monday and it is raining. Today is Friday and the sun is shining. Today is Thursday and it is raining. As we think about this, what we find is that because of that word and in there, only the first statement becomes true. And the reason for that is because when we say and, we expect both parts of the statement to be true. If either part, either the second part is false or the first part is false or both parts are false, then the statement is false. The only time an and statement is true is when both parts are true. Now let's take a look at or. Same statements, same assumption that today is a sunny Monday. Today is Monday or the sun is shining. Today is Monday or it is raining. Today is Friday or the sun is shining. Today is Thursday or it is raining. Think about the truth value of each of those statements based on our assumption that today is a sunny Monday. And what we find is that we agree that the first one is true where both parts are true. But saying or is different than saying and. We're saying one or the other. So today is Monday or it is raining is a true statement. This part is true. Today is Friday or the sun is shining. This part is true, making the statement true. The only time, in fact, that an or statement is false is when both parts are false. So or statements are true when one piece is true, or the other piece is true, or they're both true. Those make true statements. All right, looking at negation. Not today is Monday. Well, today is Monday is a true statement, and the negation of that makes that a false statement. Today is raining is a false statement, and the negation of that makes it a true statement. One of the things that we have to pay attention to is the order of operations. Just like in algebra and arithmetic, we've got an order of operations for multiplication, division, addition, and subtraction. We have an order of operations for our logical operators as well. You'll see that not is way up here, followed then by and, followed by or. Of course, just like in arithmetic, we can use parentheses to override that order of operations. Let's take a look at some examples. If you have your worksheet, you can pull that out now. If not, the questions are right in front of you. This is question number 1, letters I through N. You're going to take a few minutes. You're going to look at the information that's given up here, and then you're going to determine a true or false value for each of the statements that are written there. So pause the video now and answer these questions. Okay, so looking at the first statement, 12 is less than 24, so that's true. Yes, no is not equal to n, so that's false. So I have true and false. I need both parts to be true for an and to be true, which makes this statement false. 42 is greater than 35, so this is true. 3.5 is not less than 3.2, so this is false, but true or false results in a true. So notice, first two problems, I had true and false, gave me false. True or false gives me true. Next one, 42 is less than 50, so this is true. Password equals open sesame, so this is true. True and true makes the whole statement true, but there's a set of parentheses wrapped around the whole thing with a negation. So if the whole statement is true, then when I negate that, it becomes false. On the next one, notice that the negation is not across the whole thing, it's on each part. So 42 is less than 50, true, it becomes false. Password is equal to open sesame, it's true, it becomes false. And I get false or false, which gives me false. On this one, the order of operations really matters here because if you just go left to right, you're going to find out that this statement is false. But if you pay attention to the order of operations, and the order of operations says that and happens before or, then we end up with a different result. So this is true, and this is false. True and false gives me false for this whole piece. But 3.5 is greater than 2.0, so now I've got true or false, and that gives me true. Finally, I've got this whole string of ands going across here. And the first one says age is less than or equal to max age. Well, 42 is not less than or equal to max age. This becomes false. And since everything in here is an and, we immediately know that the whole statement is false. We don't have to look at anything else, and that's called short circuiting. Computers do that a lot. They realize that if this is all ands, that all of the parts have to be true. And as soon as they find one part that's false, they don't even bother checking the rest of it. That's automatically a false statement. Different if it's ors, but in this case, it's ands. All right, next piece. We're going to write the following phrases as JavaScript conditions. We're using meaningful variable names where appropriate. If you have your worksheet, this is question 2. We're doing letters E, F, H, I, and J. E, F, H, I, and J. And if you don't have the worksheet, obviously they're right in front of you. So pause your video now and answer these questions. All right. The secret code is equal to abracadabra or voila. A lot of people are going to want to write this as code equals abracadabra or voila, but we understand that we have to write complete relations on both sides. So this becomes code equals abracadabra or code equals voila. The username is not equal to employee number 0. Now, we did this in the last one using the not equals relational operator. Today, I'm going to use the equals relational operator, and I'm going to use negation on that. So I'm going to say username equals employee number 0, and then I'm going to negate that out front. The user's choice is not equal to 1, 2, or 3. That actually becomes not choice equals 1, and choice equals 2, and choice equals 3. This not should actually be outside of the parentheses here. Sorry, that's my error. So it should be a negation out there. Player position at x equals 100, y equals 50, x pos equals 100, and y equals 50. The audition number is between 100 and 199 inclusive. That means that it can be these numbers. Exclusive would mean that it can't be these numbers. So inclusive means greater than or equal to, less than or equal. So odd num greater than or equal to 100 and odd num less than or equal to 199. Okay, so that's our logical operators, and that gives us some compound conditions. Now, uh, compound conditions work the same as basic conditions in terms of program flow. The condition still goes in this spot and directs everything. So it's just a longer condition. An alternative to compound conditions is to nest conditions. So if we go back to the discussion we were having the other day, where we were talking about being able to drive, we can now say if age is greater than or equal to 16 and has permit equals true, that they're able to drive. But this doesn't give us a whole lot of information if one of these is false. We don't know whether they're under the age of 16 or if they don't have their permit. So in some cases, instead of using a compound condition, we use nested condition. Remember, I told you that inside these brackets of a condition, we can write any valid code. Well, sometimes that valid code is another condition. So if age is greater than or equal to 16, then I check if they have their permit, and then I say you're old enough to drive. These two things do the same. But by nesting conditions, I can drill down a little more and get a little more specific. So here's the compound condition. So if this is true, you can drive, and otherwise I just say you can't drive. But if I go with nested conditions, then I can say, all right, if we get to here, you can drive. Otherwise, if this doesn't execute, it's because this was false, which means you don't have your permit. Or we never got in here because this was false, which means you're not old enough to drive. So sometimes I don't need this kind of feedback, but if I do, it's much harder to do with a compound condition. I can do it with nested conditions. There is a special case of nested conditions, and that's when I have mutually exclusive options. That means one or the other, but not both can be tested. For example, what grade are you in? You're in ninth or 10th or 11th or 12th grade. You're not going to be in multiple grades at the same time. So we can write that using an else if chain. And when we write an else if chain, only one of the possible paths will execute. So I have four possible paths here. I've got grade less than or equal to 5, grade less than or equal to 8, grade less than or equal to 12, and everything else. We're going to take a look at how this works. So let's say that we input that we're in grade 3. Well, 3 is less than or equal to 5. And so this code is going to execute. And if this code executes, none of the rest of it does, and it continues with the program down here. In another case where we enter 7, 7 is not less than or equal to 5, so this fails. And then it comes here and it says 7 is less than or equal to 8, and that's true, so that executes. Notice that I don't have to write that it's less than or equal to 8 and greater than or equal to 6 because it already failed this test, which means it's not 5 or below. Now I'm just checking if it's 8 or below. All right, next input, we're going to input 12. It checks the first one and fails. It checks the second one and fails. It checks the third one and has success. So it skips this else and then comes down to complete the program. And finally, if I put in 14, fails the first and skips, fails the second and skips, fails the third and skips, and then executes the final, and then continues on with the rest of the program. All right, this brings us to the end of this lecture. As always, more info out on the website, cs.mickeyengel.com. More practice problems out on that same website, JavaScript Advanced Conditions. This is our practice problem for the lecture. A fast food restaurant has a set of value meals that users can order by number. The register program allows the cashier to enter the number and then the price is displayed. Using a window.prompt, take a number from the user between 1 and 5 and output the appropriate price. Write this program with an else if chain because this is a set of mutually exclusive options. And once you know what the output is, output it to the document. So we're using document.write. So at this point, I want you to pause. I want you to solve this problem. So pause the video, and when you're finished the problem, then you can pick back up again and see my solution. So now pause the video and solve this practice problem. Okay, welcome back. We're going to look at the solution to the practice problem. So you'll see here I'm doing window.prompt, enter your meal choice 1 through 5. I'm parse inting that. If choice is equal to 1, I output 4.45, else if choice equals 2, my output, else if choice equals 3, else if choice equals 4, else if choice equals 5, and if they input anything else besides 1, 2, 3, 4, or 5, I have this else down here, that kind of catch-all down there that just says, hey, that was an invalid selection. And so that's how we use an else if chain. Thanks for checking out this video. I hope it was helpful in advanced conditions, and we'll see you next time.